Today we will discuss what is a bucket-type steam trap. What is inside a bucket-type steam trap? How does a bucket-type steam trap work? And where is it used? Before starting the video, a request to everyone. Please subscribe to my channel and give a like to the video. A bucket-type steam trap, most commonly known as an inverted bucket steam trap, is a mechanical steam trap designed to efficiently discharge, condensed steam, and non-condensable gases while retaining live steam within a steam system. What's inside an inverted bucket steam trap? The primary components of an inverted bucket steam trap typically include body and cover, the outer casing that encloses the internal mechanism, usually made of cast iron, forged steel or stainless steel, depending on the pressure and temperature requirements. Inverted bucket. This is the key operating mechanism. It's an open-bottomed bucket, like an upside-down cup, usually made of stainless steel. It's connected to a lever mechanism. A small vent hole is typically present at the top of the bucket. Lever mechanism, a linkage system that connects the inverted bucket to the valve. This mechanism multiplies the force of the bucket to open and close the valve against system pressure. Valve and valve seat. The valve is typically a ball valve or a similar design that, when closed, forms a tight seal against the valve seat to prevent steam from escaping. The valve and seat are often made of hardened stainless steel for durability. Discharge orifice, the opening through which condensate and non-condensable gases are discharged. In inverted bucket traps, the orifice is usually located at the top of the trap body, making it less susceptible to clogging by dirt. Water seal. The trap body is usually designed to maintain a water seal around the inverted bucket to prevent live steam from escaping when the trap is in operation. Strainer, optional but recommended. Some inverted bucket traps may have an integral strainer, or an external strainer is often installed upstream to protect the trap from dirt and debris. How does it work? The operation of an inverted bucket steam trap relies on the difference in density between steam and condensate. Startup and condensate discharge. When the system is cold or at startup, the trap is full of air and/or cold condensate. The inverted bucket, being heavier than air or cold condensate, rests at the bottom of the trap. In this position, the lever mechanism keeps the discharge valve open. This allows air and cold condensate to be quickly discharged from the system, preparing it for steam. The small vent hole in the bucket also allows initial air to escape, preventing air binding. Steam enters and trap closes. While the trap is closed, as steam enters the trap, steam inside the bucket flows under the inverted bucket and gets trapped inside due to heat loss from the trap body. Since steam is much lighter than water, some steam also slowly bleeds out, makes the inverted bucket through the small vent hole at the top of the bucket. As the bucket condenses or escapes, the lever mechanism pulls the valve onto its decreases, closing the discharge orifice. This accumulation of condensate around it eventually inside condensate accumulation. When the bucket loses enough buoyancy, becomes heavier than the remaining steam, it sinks to the bottom of the trap. This sinking action, through the lever mechanism, pulls the valve off its seat, opening the discharge orifice and allowing the accumulated condensate to be discharged. Continuous cycle. Once the condensate is discharged, steam re-enters the bucket, causing it to float and close the valve again. This intermittent open and close cycle continues as long as there is condensate to be discharged. Key features and advantages of inverted bucket steam traps. Durability. They are known for their robust design and resistance to water hammer, resistance to dirt. The top-mounted discharge orifice helps prevent clogging from dirt, which typically falls to the bottom of the trap. The rapid discharge also creates a self-scrubbing action. Continuous air venting. The small vent hole in the bucket allows continuous venting of air and other non-condensable gases, which can otherwise cause air binding and reduce heat transfer efficiency. Good against back pressure. They can operate effectively even with significant back pressure in the condensate. Return line. Long service life. With only a few moving parts, they tend to have a long and reliable operating life.